Okay, tonight we will discuss for part A, which is group discussion, is our group choose question number 2. So the alphabet given is A, B, C, D, and E. The digits given is 1, 2, 3, 4, 5, and 6. So for question 2A1, ask number of ways to choose 3 alphabet from 5 alphabet. The solution is 5C3 equal to 10. Next is the question asks number of ways to choose from 6 digits. So the solution is 6C4 equal to 15. The next question asked is number of ways to arrange 3 alphabets and 4 digits. The solution is 7 factorial. 7 factorial is equal to 5040. And the last question asked for 2A1 problem is number of different security code that can be formed. The solution is 5C3 multiplied by 6C4 and multiplied by 7 factorial. The answer is 756000. So the next question is I give to Khaira Adibah.
Okay. For question 2A2, it asks us to find a number of different ways the security code can be formed if all alphabets are next to each other and all digits are next to each other. First, number of ways to arrange all 3 alphabets next to each other and 4 digits are next to each other is equal to 2 factorial. Next, number of ways to arrange 3 alphabet is equal to 5p3. Beside, number of ways to arrange 4 digit is equal to 6p4. Then we multiply these 3 numbers and we will get the answer 43,200. Okay, for the next question, I pass to Fatiha.
Okay, let me explain this question. So, we have 3 consonants which are B, C, and D. The question asks us to find out at least 2 consonants. First, we use table to show the calculation. We start with 2 consonants. Back to the previous question, the security code should consist of 3 alphabets, which is we have to add 1 vowels. For digits, we shouldn't change the rule because it is not mentioned in the question. So the calculation should be 3C2 times 2C1 times 6C4 times 7 factorial. And the answer is 453,600. For the next case, we take 3 consonants and 4 digits only. The calculation is 3C3 times 2C0 times 6C4 times 7 factorial. And the answer is 75,600. For the last answer, we should add both answer for the first and second case. So the final answer is 529,200. Table to solve this question. For the first case, we take 3 women and 2 men. The calculation is 6C3 times 462, and the answer is 120. Is we take 4 women and 1 man. The calculation is 6 for C1, and the answer is 60. And for the last case, we take 5 women only. The calculation is 6C5 and 6C5 times 4C0, and the answer is 6. For the last answer, we should add all answers shown in 3 cases, and the total is 186 ways. That's all for this question.
For question 3A1 is the question is one probability B. So the formula is probability A over B equal to probability A intersection B intersects B over probability B. We just substitute the value is probability A over B equal to 0.4. Probability A intersects B is 0.12. Just substitute and probability B equal to 0.12 over 0.4. So the answer is 0.3.
For this question, we use this formula, which is probability B given A is equal to probability B intersect A over probability of A. The question has given us information such that probability B over A equal to 0.25 and probability B intersect A is equal to 0.12. So we just substitute the value given into the formula. So it should be 0.25 equal to 0.21 over probability of A. The answer is 0.48. So to show that A and B are independent, that means probability A intersect B equal to probability A times probability of B, and the answer should be 0.12. So if we calculate probability of A times probability of B, the value are 0.48 times 0.3, and the answer is 0.144. So we can see that probability A times probability B is unequal to probability A intersect B. Thus, A and B are not independent events.
Question number 383 asks to find probability A intersect not B. First, we do probability A intersect not B is equal to probability A minus probability A intersect B. Then we substitute the value of probability A, that is 0.48, and the value of probability A intersect B is 0.12. After that, we calculate it and we get 9 per 25 or 0.36. For 3B1 question, it asks us to find probability A. First, we do probability A equal to total number of sample A per total number of sample S. Then substitute total number of sample A with the value given, that is 60, and total number of sample S, that is 125. Calculate it, then we will get 12 per 25. Next, question number 3B2 asks us to find probability A union B. To find it, first we do probability A union B equal to probability A plus probability B and minus probability A intersect B. Then we substitute it with the value that we get, which is probability A is 12 per 25, probability B is 45 per 125, and probability A intersect B is 25 per 125. Calculate it, we will get the answer 16 per 25.
So we move to the next question. It asks us to find probability A intersect B. So we just substitute the value and we will get 25 over 125, and the final answer will be 1/5.
For question B is, during 1996, a vet saw 125 cats, each suspected of having a particular disease. Of the 125 cats, 60 were female, of whom 25 actually had the disease and 35 did not. Only 20 of the males had the disease, the rest did not. The case history of each cat was documented on a separate record card. A record card from 1996 is selected at random. Let A represent the event that the cat was female, and let B represent the event that the cat was suffering from the disease. So for question 4 is, for Roman is, the question asks probability A over B. Probability A over B equal to probability A intersects B divided by probability B. So we know that probability A intersects B is 1/5 divided by probability B is 46 over 125, and the last answer is 5/9.